Okay, so I'm going to dictate some notes for you now. Your first subheading is limit definition. If f of x gets closer and closer to a number L, capital L, as x gets closer and closer to C, common C, from both sides, then L is the limit of f of x as x approaches C. This behavior is expressed by writing, and I'm going to show you the board, limit of f of x as x goes to C equals L, right? So the limit of the function, limit of f of x, as x approaches C, or as x gets closer and closer to C, is equal to L. Next subheading, determining limits graphically. It is important to remember that limits describe the behavior of a function near a particular point, and I want you to underline near a particular point, comma, not necessarily at the point itself. If we follow the graphs of the three functions below, we will see that as x tends toward 3 from the left and from the right, the functions all approach 4. Yet, the functions behave quite differently at x equals 3 itself. So here are the three functions we just spoke about, right? This first one, let's look at them individually. For this first one, so obviously the black is our curve. It's a solid line right through. There are no holes, no gaps. It's a solid line. For this one, f of 3, right, the function value, which is not what we're concerned about, but I just want you to compare it to the limit value. The function value at 3, so f of 3, so our function at the value 3, right, is equal to, if we read off our graph, it is equal to 4. But also, our limit is 4. Why? We're going to look at it this way. Let's say we're approaching 3 from the left. So we're coming from this side. So we're on our graph, and we're approaching this spot right here. Because at this spot, our x is 3. So, pretend we're driving on a road. So we're driving, we're approaching this spot. And it would seem as if we're heading towards this number here, 4, because at this spot the function takes the value 4. So while we're driving along headed towards x equals 3 from the left, it's apparent that we're heading towards this y value here, which is 4. From the right as well, if we're on the same curve and we're approaching x equals 3 from the right, so we're coming along on the graph here, it would seem as if we're approaching the number 4, the y value 4. And so our limit of the function as x goes to 3 is equal to 4, right? So as x goes to 3, and this means we're talking about both from the left and from the right. Okay, so as x goes to 3, both from the left and from the right, the limit of the function is 4. So the function approaches a y value of 4. Now if we look at graph number 2, we have the same sort of curve. The only difference now is that at x equals 3, there is a hole, right? And we denote it with a little circle, an empty circle. So there is a hole at x equals 3. So my curve isn't solid right through. There's a hole right there at x equals 3. And I actually have a dot further up. So we expected a dot right here. We expected a solid curve. But we find that there's a hole there. And then there is a dot right above it on the same, in the same x value, x equals 3. Now what this means is that my f of x, right, is actually equal to this value here, not here. My function is actually defined, my function at 3 rather, is actually defined at this point here, which means f of 3, I would actually read this y value is 5, right? Not where I expected it. Good. The limit value, however, let's look at the limit value. If we're approaching 3 from the left, right, so we're on the curve going towards this point here. We're going towards this point. If we're going from the left, x equals 3 is here, so we're going towards this point. And this point actually has a y value of 4. From the right, same thing. We're driving along, we don't know exactly what happens here, right? But we know we're approaching this point, x equals 3, and it's apparent that we're going towards a y value of 4, even though if you look at your graph, you'll see that it's not actually defined there. But for limits, we don't care about if it's defined there. And that's the point of this one, is that I wanted to show you that no matter what is actually happening at x equals 3 in this case, right, my limit is actually still 4. So the limit of f of x as x goes towards 3 is equal to 4, because we're going towards this point, and at this point my y value is 4. Okay, so notice my function value and my limit are different. In the first one they were the same, but in this one they're different. Let's look at the third and final one. Here we have same curve again, right? Looks just like these two. The difference is there is a hole or a gap at x equals 3, and there is no dot anywhere along that x equals 3, right? What that means is that the function value at 3 is undefined, right? So f of 3 is undefined. There is no solid dot anywhere at x equals 3. Unlike this one where there was a solid dot above, this one doesn't have a solid dot at any point along x equals 3, and so I say my f of 3, or rather f of 3 is undefined. The limit, however, if we're going towards 3 from the left, so we're on the curve and we're heading towards x equals 3, which is this spot, right? Going along, at this spot your y value is 4. And even from this side, from the right side, as you're heading towards x equals 3 from the right, so you're on the road and you're driving towards this spot, at this spot, even though there's a gap there, we don't care about what actually happens at that point. We only care about where the function seems to be going, and it seems to be going towards this point here, and at this point your y value is 4, which means your limit, or the limit of f of x as x goes to 3 is equal to 4. So all 3 graphs had the same limit as x goes to 3. They're all 4, but the function values themselves differed. Here my f of 3 was 4, here my f of 3 is 5, here my f of 3 is undefined. But when you're doing limits, you don't care about the f of, right? You don't care about what's actually happening at that particular point. You're only concerned about as x approaches a particular number. Continuing with our notes, the figure below shows the graph of two functions that do not have a limit as x approaches 2. The limit does not exist in A because f of x tends toward 5 as x approaches 2 from the right and tends toward a different value 3 as x approaches 2 from the left. The function in B has no finite limit as x approaches 2 because the values of f of x increase without bound as x tends toward 2 and hence tend to no finite number. Here are the two graphs, right? This is a black solid horizontal line that stops here, and then we have another one that stops here. With this one, sorry, this one has a gap right here, an open circle. Now, what this means, as I explained before, if we're looking at 2, the actual function value f of 2 would be this spot here, not here, because here has an open circle. So f of 2 would actually be equal to 3. But the limit as x approaches 2 from the left and from the right, look what happens. If you're approaching 2 from the left, right, it means you're on this road, you're on this graph. You're approaching this value here, right? So you're on this graph, you're approaching this spot, and at this spot, your y value is 3. But from the right, if you approach 2 from the right, what you find is that you're on this graph, because you're coming from this side, so you're on this graph, and you're approaching this spot, right, at x equals 2. So as you approach 2, you're approaching this spot, which has a y value of 5. So your left-hand limit, we call it, is 3. Your right-hand limit is 5, meaning you're approaching 2 from the left. It would be a value of 3, but if you approach from the right, right, the same x as 2, you are approaching a y value of 5. So 3 from the left, 5 from the right means that the limit does not exist. So we would write lim of f of x as x goes towards 2 does not exist. Similarly, for this one, f of 2, first of all, is undefined. Not that we're concerned about it, but we just want to compare values. So f of 2 is actually undefined. The graph never actually equals 2. Also, your limit doesn't exist, and the reason for that is as you approach 2 from the left, so you're on this graph, what is happening is that your y value is increasing and increasing and increasing and getting bigger and bigger and bigger and bigger without any bound, right? And a limit must have a finite value. So in this case, as x approaches 2 from the left, your y value is actually increasing without bound. So right away we can say the limit doesn't exist. But the same thing happens from the right side. If we're approaching 2 from the right, so we're on the graph over here, the y value is increasing and increasing and increasing without bound. And so we would say that the limit for this one also does not exist.